In this video, we're talking about 0 as an exponent and the fact that anything raised to the power of 0 is going to be equal to 1. So if we have a variable like x raised to the power of 0, this is going to be equal to 1. If we have a whole number like 3 and it's raised to the power of 0, this is going to be equal to 1. If we have some product of variables like x times y times z, and we raise this product to the power of 0, that's going to be equal to 1. 1,000, a very large whole number raised to the power of 0, will be 1. And some binomial expression like this, any polynomial, because the entire thing is raised to the power of 0, we've put it in parentheses and then raised it to 0, it's going to be 1, no matter what the value of this 4x plus 1 ends up being if we plug in some other value for x. The point is, anytime we raise something to the power of 0, it's going to be equal to 1. One thing I can do to show you that this is true is we can use the quotient rule for exponents. So for example, if I have x cubed divided by x cubed, looking at this on its own, I can see I have x cubed over x cubed, the numerator and the denominator are the same, so I can say this is equal to 1. But if I solve this using the quotient rule for exponents, I recognize that my bases are the same. I have a base x here and a base x here. And the quotient rule for exponents tells me that when that's the case, I can take my base of x, and I can take the exponent from the numerator, 3, and subtract from that the exponent in the denominator, 3. So I get x to the 3 minus 3. Well, of course, that's just x to the 0, and I can say that x to the 0 is 1. So intuitively, because we had the numerator and denominator the same, we knew that this fraction was equal to 1, but if we use the quotient rule for exponents, we can prove that it's equal to 1, which allows me to draw the conclusion that this step, x to the 0, goes to this step, that this is true. So just remember, anytime you have something raised to the 0 power, no matter what it is, the value is going to be 1.